This is a basic video demonstrating the differences between a vacuum-assisted and the VST Platinum Central Vac vapor collection systems. Here is a system-level view of a gas station with a VST Platinum Central Vac vapor recovery system installed. Note that there are both air and fuel vapor particles in the underground storage tank, represented by blue and orange dots, respectively. Now, let's introduce the competitor to our comparison, the vacuum-assisted vapor recovery system. The Vac-Assist system has something the VST system doesn't, a vacuum pump installed in each dispenser. The vacuum pump runs whenever fuel is being dispensed, returning a set volume of air and fuel vapor mixture to the underground storage tank for each unit of liquid fuel dispensed. By comparison, the VST system functions by collecting vapor using both the vacuum created by the fuel leaving the UST and the pressure created by the fuel entering the vehicle's tank. This minimizes excess air ingestion and UST pressure. Let's compare the two vapor recovery systems side by side while fueling a car equipped with an onboard refueling vapor recovery, or ORVR, system. Note that we have added a pressure gauge in the bottom left corner of both sides to show the pressure of the underground storage tank while fueling. The VST system is seamlessly compatible with an ORVR vehicle, while the Vac-Assist system is not. The VST system on the right returns only what fuel vapors it can collect to the UST. Because this volume of vapors is less than the volume of liquid fuel dispensed, the pressure in the UST will decrease. By contrast, the Vac-Assist system on the left is set to return a specified volume of air and fuel vapor mixture for each unit of liquid fuel dispensed. Since the system cannot recover only vapor to satisfy this requirement, it ingests air to make up the difference. This air is added to the underground storage tank, which in turn promotes the evaporation of liquid fuel, leading to overpressurization. This difference in performance is also present in a scenario where the vehicle fueling is not an ORVR-equipped vehicle. Both systems again return the same amount of fuel vapor, but the Vac-Assist system will ingest extra air. This ingestion of air again leads to overpressurization of the underground storage tank. Vacuum-assisted systems have a setting that returns a set volume of air and fuel vapor mixture for each unit of fuel dispensed. This ratio is typically set to be greater than 1:1, meaning that the system is set up to return a higher volume of that mixture than liquid fuel it dispenses. This is due to the characteristics of the nozzle of a Vac-Assist system. The nozzle of a Vac-Assist system does not have a seal on the fill neck of the vehicle, and therefore can ingest air just as easily as it ingests fuel vapors. Note that the Vac-Assist nozzle on the left has a gap between the hood or boot of the nozzle and the fill neck of the vehicle, while the VST nozzle on the right has a tight seal. This seal does not allow air to enter the system and ensures that only fuel vapor particles are returning to the underground storage tank.